Welcome to Outbreak Brief, the podcast that takes you inside the world's most dangerous infections. Today, we're taking a deep dive into a stack of historical case studies, epidemiological reports, and some pretty intense biodefense threat assessments.
Yeah, we're looking at a truly ancient villain today.
Exactly. Our mission is to decode a pathogen that doesn't just infect its hosts, it lies in wait. You're dealing with an organism that can sit perfectly preserved in the dirt for decades or even centuries, just waiting for the precise moment to strike.
It's just terrifying.
Right. Today, we are exploring Bacillus anthracis, the bacteria behind anthrax.
It is arguably the ultimate biological survivor. And, when you realize exactly what it is capable of and the microscopic weaponry it carries, it completely changes how you look at the ground beneath your feet.
To understand just how unbelievably patient this pathogen is, I want to take you to the summer of 2016. So we are on the remote Yamal Peninsula in Siberia.
Way out in the tundra.
Yeah, a landscape that is usually just frozen solid. But this brutal, unprecedented heat wave rolls in. And the permafrost ground that has literally been frozen since before the Second World War, it begins to thaw.
It just turns into this thick, shifting mud.
Exactly. And as that ice melts, something hidden deep in the soil is exposed to the open air. It's a 75-year-old reindeer carcass.
Which, sounds like just a fossil, a relic.
But it's not. It is a biological time bomb. Because shortly after the ice melts, dozens of nomadic herders in the area fall violently ill, and thousands of local reindeer just suddenly drop dead.
And when scientists rushed in to analyze what was happening, what they found was chilling. The pathogen ravaging the peninsula hadn't just blown in on the wind from, a neighboring herd. It had woken up.
Oh, wow. So it was there the whole time.
The whole time. The DNA of the bacteria infecting these people perfectly matched strains that had been frozen in that soil for nearly a century. The bacteria wasn't dead. It was merely dormant.
That is wild.
Right. This isn't just a disease. It is a pathogen capable of time travel.
Okay, let's unpack this. How on earth does a bacteria survive in frozen mud for 75 years?
All right.
I mean, bacteria are living things, right? They need nutrients and warmth.
They usually do, yeah. But to understand how anthrax survives, you have to look at its two distinct life phases. So under a microscope, Bacillus anthracis is a large, gram-positive, rod-shaped bacterium.
Okay.
When it is actively multiplying in a host, it links together in these long chains. They look exactly like a row of boxcars.
Boxcars, right?
Yeah, this is its vegetative state. And in this active state, it's actually quite fragile. It can be killed by sunlight or heat or, basic disinfectants.
But it doesn't stay in that fragile boxcar state when it hits the soil, does it?
No, it doesn't.
Because the secret to its immortality is the spore. I was reading the microbiology reports for this deep dive, and the best way I can describe the anthrax spore is to think of it as a heavily armored, microscopic escape pod.
That's a great analogy, actually.
Thanks. So when the bacteria senses that its environment is becoming hostile-like, maybe the animal it infected just died and it's running out of food, or the temperature drops rapidly, it essentially packs its essential DNA into this incredibly dense, dehydrated core.
Right, it bunkers down.
It builds a specialized membrane and a thick armored outer coat. And this escape pod is practically indestructible. I mean, it resists boiling heat, ultraviolet radiation, toxic chemicals, and literally decades of extreme dehydration.
What's fascinating here is the sheer lethal sophistication of its genetic machinery once that escape pod finally opens inside a warm body. Because it's not just a tough shell.
It's armed.
Highly armed. The true weaponry of Bacillus anthracis is carried on two distinct extra chromosomal pieces of DNA called plasmids. Specifically, PX01 and PX02.
The extra chromosomal, you mean it carries its weapons in like a separate biological briefcase outside its main genetic code?
Exactly. It's a modular weapon system. So one plasmid, PX02, builds a specialized capsule around the bacteria out of an acid.
And what does that do?
It acts as a chemical invisibility cloak. It completely hides the bacteria from your immune system's radar.
Wow. Okay.
And the other plasmid, PX01, manufactures a highly complex three-part chemical weapon. You've got protective antigen, edema factor, and lethal factor.
And these three work together like a lock and key, right?
Precisely. The protective antigen, we call it PA, acts like a microscopic syringe. It docks onto the outside of your healthy cells and creates a channel. Then it physically injects the other two toxins inside.
And that's when things go Really wrong for the cell.
Yeah. Once inside, the edema factor drastically alters your cellular water balance, causing massive, devastating swelling. Meanwhile, lethal factor acts like a molecular pair of scissors. It just slices up the cell's internal communication pathways.
It's just a devastating, indestructible, heavily armed bacteria, and humanity has been battling it for a very long time.
A very long time.
The name anthrax actually comes from the ancient Greek word for coal because of the terrifying coal-black crater lesions it leaves on the skin. And, it has really shaped medical history.
Yeah, back in the 19th century, it was known as wool sorters disease.
Right, because textile workers kept dying after handling infected sheep fleeces. And Robert Kugak actually used Bacillus anthracis to officially prove the germ theory of disease. It's literally the poster child for modern microbiology.
But our relationship with this bacteria took a very dark turn in the 20th century. We stopped just trying to cure it and started trying to weaponize it.
Which is terrifying to even think about.
It is. And that leads to one of the most chilling incidents in modern public health history, the 1979 outbreak in the Soviet city of Sverdlovsk.
Oh, this story is wild.
Scores of people suddenly started dropping dead of severe anthrax just out of nowhere.
And the KGB immediately tried to cover it up. They claimed all these victims had simply eaten contaminated meat bought on the black market. Just a localized food poisoning tragedy. Nothing to see here.
But that lie fell apart, thanks to the incredible detective work of investigators, including American scientists like Matthew Meselson.
Right, because Meselson didn't just look at the bodies. He looked at a map. He plotted the exact locations of every single victim. And he noticed they formed a narrow, perfectly straight line.
Extending exactly downwind from Compound 19.
Yeah, a secret Soviet military microbiology facility. He proved it wasn't bad meat. It was an accidental wind-borne aerosol release.
A tiny mistake at a bioweapons lab sent an invisible plume of weaponized spores floating quietly over the city.
Just breathing it in without knowing. And we saw that exact same terror weaponized intentionally in the United States in the fall of 2001.
The anthrax mailings.
Right. Envelopes containing heavily refined, aerosolized anthrax spores were mailed through the U.S. postal system to media outlets and congressional buildings. It shut down the government, infected 22 people, killed 5, and cost over $1 billion to clean up.
Here's where it gets really interesting. Because the specific strain of anthrax used in those 2001 attacks has a bizarre origin story of its own.
Oh, the Ames strain.
Yeah, it's known globally as the Ames strain. But it didn't actually originate in Ames, Iowa. The biodefense reports show it was isolated in 1981 from a single dead cow in Sarita, Texas.
So why is it called Ames?
Well, researchers shipped this highly virulent Texas strain to an Army Medical Research Institute, but they packed it in an old, reused box that happened to have a return address from Ames, Iowa.
Wait, really? A reused box?
Yeah, the label just stuck. A simple recycling mistake gave the name to the source material for the worst bioterror attack in U.S. history.
That is a wild piece of history. But, if we connect this to the bigger picture, the 2001 attacks highlight the most vital thing you need to understand about anthrax transmission.
Yeah.
It was mailed in envelopes that infected 22 people, but it didn't spark a global pandemic.
Exactly. And why is that? Because the basic reproduction number, the R0 for human-to-human transmission, is effectively 0.
Meaning it's not contagious.
Right. It is a zoonotic disease. You cannot catch anthrax from someone coughing on you in an elevator. You have to get it directly from the environment.
Which makes the journey of that spore so critical. There are 4 distinct pathways these spores can take to invade your body.
Right. Let's go through them.
First is cutaneous. This happens when a spore enters through a microabrasion or a scrape in your skin. This is often from a farmer handling infected livestock hides. Second is inhalational. This is breathing aerosolized dust straight into your lungs, like the workers at a wool mill or the victims of the 2001 envelopes.
Then third is gastrointestinal.
Right, eating the raw or undercooked meat of an infected animal. And fourth, this one is pretty new, an exceptionally rare route called ingestion anthrax. It was identified in Northern Europe among intravenous drug users whose heroin supply had been contaminated with bone meal or soil containing spores.
But regardless of the door it uses to get inside, the mechanism of invasion is just brilliantly sinister. When those spores enter your body, your immune system's frontline defenders, these specialized cells called macrophages, swat them.
They act like the bouncers.
Yeah, they rush in and swallow the spores, intending to destroy them with acid.
But they don't destroy them. This is the part that completely blows my mind. The body's own immune system unwittingly acts as a free taxi service.
A microscopic Trojan horse.
Yes. The macrophages carry the heavily armored spores directly into your lymph nodes, and your lymph nodes are this warm, nutrient-rich environment. So what happens?
The escape pods pop open.
The spores germinate into their vegetative boxcar state. They multiply at a staggering rate, throw on their chemical invisibility cloaks, and begin flooding your bloodstream with those deadly syringe and scissor toxins.
And because you can't catch it from your neighbor, the people truly in the crosshairs of this disease are in highly specific risk groups. It's largely an occupational hazard.
Right. If you are a veterinarian, a livestock producer, or a worker in a slaughterhouse, you face this microscopic threat on a daily basis.
And geographically, it's a massive issue. An estimated 1.83 billion people live in at-risk arid and temperate regions, primarily in Central and South America, Sub-Saharan Africa, and parts of Asia and Eastern Europe.
Where there's a lot of livestock.
Exactly. In these areas, human outbreaks almost always shadow outbreaks in livestock.
The epidemiological reports also talk a lot about anthrax weather. At first, I thought that meant wind, but it's actually about soil chemistry and extreme climate shifts.
Yeah, it's a very specific environmental trigger.
Anthrax spores thrive and are preserved best in alkaline, calcium-rich soils. When you have a prolonged, severe drought, the earth cracks and vegetation dies. Then heavy rains sweep in, turning the cracked earth to mud and floating those long-buried spores right up to the surface.
Right onto the new grass.
Yep. Grazing animals ingest the grass, die, bleed into the soil, and the cycle of infection begins anew.
There are also bizarre occupational outliers, like welder's anthrax.
What does welding have to do with soil?
It's a newly identified rare and severe pneumonia found in metalworkers. It's caused by bacteria in the same family that are incredibly similar to Bacillus anthracis. They essentially exploit the lung damage caused by welding fumes.
That is incredibly specific and scary. So if a tannery worker inhales a spore or a farmer gets it in a cut, what does the disease actually feel like as it takes hold?
It depends entirely on that pathway of entry. Let's start with cutaneous anthrax, the skin infection. It starts deceptively small.
Like a bug bite.
Yeah, you might notice a painless, itchy bump on your arm and assume it's just a spider bite. But over a day or two, the tissue begins to die. It morphs into a fluid-filled blister and then ulcerates into a necrotic, coal-black crater on your skin.
An eschar.
An eschar, exactly. And thanks to the edema factor toxin, the tissue all around that black crater swells up massively with fluid.
It sounds visually terrifying, but cutaneous anthrax is actually the most survivable form. Inhalational anthrax is the true nightmare. If you breathe it in, the disease has a biphasic or two-part progression.
The first phase is a deceptive prodrome.
Yeah, you get a mild fever, fatigue, muscle aches, and a dry cough. You think you just caught a seasonal flu.
But after a few days, you hit the second phase, and it is an abrupt, violent crash. The patient suddenly develops severe shortness of breath, massive sweating, and goes into systemic shock.
It happens that fast.
Very fast. If a doctor takes a chest x-ray at this point, they will see a heavily widened chest cavity. This is hemorrhagic mediastinitis. Massive bleeding and fluid buildup in the space between the lungs. The toxins are literally destroying the vascular structures in the chest.
And for the gastrointestinal and injection routes, you are looking at severe abdominal pain, bloody diarrhea, and deep, rapidly spreading necrotic tissue death at the injection site.
Now, this raises an important question. With all this massive tissue death, bleeding, and bacterial multiplication going on, if a surgeon looks at an anthrax lesion or an infected lung, there is almost no pus.
Wait, really? None. But pus is just an accumulation of dead white blood cells, right? It's the standard hallmark of any bacterial infection.
Normally, yes. Your immune cells swarm the site, die fighting, and form pus. But remember lethal factor, the molecular scissors. That toxin is so ruthlessly efficient at paralyzing your immune system that it actually forces your white blood cells to commit suicide before they can even mount a localized inflammatory response.
The body's defenses are completely hijacked. So what does this all mean when a patient finally reaches the hospital? I mean, the reality is a desperate race against time. The mortality rate for untreated inhalational anthrax is a staggering 85 to 90%.
And the treatment protocol reflects that urgency. You don't just take a quick Z-Pack and go home. Patients require immediate intravenous multi-drug therapy. We're talking heavy hitters like ciprofloxacin, meropenem, and linezolid given in combination through an IV.
And even after the patient stabilizes, they have to transition to oral antibiotics for up to 60 days.
Yes.
60 days of antibiotics. That is a brutal system-wrecking regimen. Why do they have to stay on them for 2 solid months?
Because of the escape pods.
Ah, the spores.
Right. When you breathe in thousands of anthrax spores, they don't all germinate in your lymph nodes at the exact same time. Some can lay completely dormant in your lungs for weeks.
So if you stop the antibiotics at day 14, thinking you're cured.
A dormant spore could wake up on day 20, germinate, and kill you. The 60-day war ensures that every last spore that eventually hatches is immediately met with a lethal dose of antibiotics.
But there's a massive clinical catch here. Antibiotics only kill the living bacteria. If you arrive at the hospital late and the bacteria have already multiplied and released their chemical weapons into your bloodstream, killing the bacteria isn't enough to save you. The circulating toxins will still destroy your cells.
Precisely. That is why doctors must also deploy specialized antitoxins alongside the antibiotics. We use therapies like Anthracis, which is a purified human immune globulin, or monoclonal antibodies like raxibacumab.
And those go straight into the IV.
Given intravenously, yeah. They act like molecular sponges, hunting down and neutralizing the protective antigen poison in your blood before it can dock onto your cells.
It is a grueling, uncertain battle, which is why curing the infection is the hardest path. Preventing the infection from taking hold in the first place is the ultimate public health goal. Thankfully, we have a shield. An anthrax vaccine does exist.
But you can't just stroll into your local clinic and request an anthrax shot before a hiking trip.
No, definitely not.
The vaccines, like Biothrax and Cifendes, are tightly controlled and reserved for very specific populations.
Right. For high-risk individuals like military personnel deploying to certain regions or scientists working in biodefense labs, there is a pre-exposure prophylaxis schedule, and it is a major commitment. It requires 5 separate shots over 18 months, followed by annual boosters just to maintain that active immunity.
The vaccine is also a critical tool after an exposure.
Like in a terrorist attack.
Exactly. During a bioterrorism event, if you breathed in the spores, public health officials would put you on the 60-day course of antibiotics, plus administer the vaccine. The antibiotics act as a temporary shield to keep you alive, while the vaccine works to build a bridge of active immunity, teaching your body how to fight off the toxins itself long term.
But the vaccine is the very last line of defense. In the real world, the most effective prevention happens way before a needle touches your arm. It happens in the workplace. If you work in a tannery or a wool mill, the safety protocols are incredibly strict. You must never vigorously shake or beat an animal hide.
Because that sends invisible clouds of dried spores into the air you breathe.
Exactly. The workspaces have to be continuously cleaned with specialized high-efficiency particulate air, or HEPA, vacuums to capture the dust.
And at the broader public health level, the true frontline soldiers in the war against anthrax aren't medical doctors, they are veterinarians.
Wow, really?
Yeah. Routine vaccination of livestock in endemic areas prevents the animals from becoming reservoirs. And if an animal does die of anthrax, the carcass cannot simply be buried.
As we saw in Siberia.
Right. Burying it just puts the time bomb into the soil. It must be carefully incinerated to completely break this cycle of infection.
Now, in a human healthcare setting, handling an anthrax patient is surprisingly straightforward when it comes to contagion. Because it doesn't spread person to person, hospitals don't need highly restrictive, negative pressure isolation rooms.
Standard contact precautions are highly effective. Wearing N95 respirators, gloves, and eye protection to avoid contact with infected fluids or lingering spores on the patient's clothing.
So with all these modern countermeasures, the livestock vaccines, the strict workplace protocols, the advanced multi-drug antibiotics, and the monoclonal antitoxins, where does humanity actually stand in our war against anthrax today?
Well, in the United States, the picture is incredibly reassuring. It is exceedingly rare. Since 2006, there have only been 9 confirmed or probable human cases reported to the CDC.
But the global reality is quite different. The World Health Organization estimates that between 2,000 and 20,000 human cases still occur annually worldwide.
And the vast majority of these are the cutaneous form, happening in agricultural regions that lack the funding or infrastructure for widespread, consistent livestock vaccination programs. Globally speaking, anthrax is far from eradicated. It is an endemic reality that is simply managed.
Which brings us to the future of biodefense. If anthrax is successfully contained in the developed world, what keeps epidemiologists awake at night?
There are two massive looming threats. The first is intentional.
Bioterrorism.
Yes, because anthrax spores are incredibly stable, resistant to heat and drying, and relatively easy to cultivate if you have the right equipment. The threat of an aerosol bioterrorism release remains a Tier 1 biodefense priority. The nightmare scenario is a coordinated release from a drone over a major metropolitan area.
The second threat isn't driven by human malice. It's driven by climate change. Remember our cold open with the reindeer in Siberia?
The thawing permafrost.
Yeah. As global temperatures rise and the permafrost continues to melt at unprecedented rates, we are going to see more of these zombie outbreaks. Ancient frozen carcasses thawing out and releasing century-old strains of Bacillus anthracis back into the modern ecosystem.
But we aren't helpless against either of these threats. Our scientific arsenal is evolving rapidly. One of the greatest new tools we have is canonical SMP analysis.
SMP stands for single nucleotide polymorphism, which is essentially genetic fingerprinting, right?
Exactly. We can now map the entire genome of a single anthrax spore and trace it back to its exact geographic and evolutionary origin.
That's incredible.
We know exactly which sublineage it belongs to, whether it came from a specific grazing field in Texas or a soil sample in Eastern Europe. This deeply deters state-sponsored bioweapons programs because it completely removes their anonymity. If a bad actor uses anthrax as a weapon, we will trace the genetics right back to the exact laboratory it was engineered in.
It is a remarkable scientific achievement. But, looking at the sources, it creates this profound, almost terrifying double-edged sword.
How so?
To defend against the worst strains, we have to map their genomes perfectly. But by creating a perfect genetic database of the most lethal anthrax strains on Earth, we are theoretically creating a blueprint. A blueprint that, if it falls into the wrong hands, tells a bioterrorist exactly which mutations make the perfect weapon. In our quest to build the ultimate defense, we might be indexing the ultimate biological threat.
It is a permanent ethical and scientific tightrope. We don't have the luxury of just wiping this disease off the map. We share a planet with an immortal pathogen.
Anthrax isn't an invader from outer space. It isn't a fragile virus that we can hunt down and eradicate through human vaccination, like smallpox. Bacillus anthracis is a natural, permanent resident of the Earth's soil.
It belongs here just as much as we do.
Because we cannot sterilize the entire planet, we will never truly defeat it. So the next time you are out on a hike or walking through a dry, dusty field after a heavy rain, just think about what might be resting beneath your boots, waiting in the dark, in a microscopic escape pod. For 100 years, just waiting. Stay informed. Stay prepared. This has been Outbreak Brief.